Hello, this is a lesson on solving equations, continuing our conversation about equations earlier. So the essential question is, how do you solve an equation that contains a quadratic or a radical? So we're going to talk about two specific different types of equations. Now, if you remember how to do these, you can always pause and just do them. And again, do them on your own and then come back. So how do I know it's a quadratic? And this is something you have to know. Again, every problem will be slightly different and you have to be able to recognize it. So hopefully you know that because of this, with a square, that is a quadratic or a graph, a parabola. So what you're looking for is the x-intercepts, right, of your parabola. And we should also know, when you have that, one of the major ways to solve it is factoring. Now, that's not the only method, but that is one of them. Now, there's lots of different ways to factor. I just look at it. Some people, you may do the box and the diamond. I go straight to parentheses. So you do the method that you are comfortable with. I know that here, but you are looking for the factors of the last and the factors of the first, and hopefully when you multiply, the middle comes out. So I know that the factors are 7 and 1. Now, when you're looking at 4, a 4x squared, it could be 4 times 1 or 2 times 2. Now, one of a trick or strategy to recognize that if this number in front and this number in back, if you add or subtract them and you get this number, then it's actually the numbers that you see. It's broken down factors, it's that number. So I know that 7 minus 4 is 3. So I'm going to do 4 and 1. So knowing that, and I know this is going to be an x, and I know this is going to be x, and the next question is, well, where should I put it? If I put the 4 here, it's going to get multiplied by the 7. Well, that's 28, and that's too big. So again, we just want to subtract them to get that 3. So we're actually going to put them next to each other so that they do not multiply each other. So this x is going to be 1. I know that the 3 is positive, so the number 7 is bigger than 3, so that's going to be positive, and this is going to be negative. Now, if you multiply it out, you will get the one above. And for those, you should just know, some of you can do it in your head, that what you are doing is you are making each parentheses 0. So this is 1, and this, if you solve it, you can always do a shortcut, and there you are. Generally, for these, you will have 2 intercepts because of this. You can have 1, you can also have none. All right, so let's look at this next one. All right, so if I'm thinking about it this way, right? Well, that's x and x, and then, okay, I can have 2 and 2. Can that get me 8? No. 4 and 4. Wait, but that's not right. That would be 4 and 1. Well, that doesn't get me 8. So the factoring doesn't work. So what happens? Do you remember? You have 2 different choices. You can complete the square or use the quadratic formula. I'm going to use the quadratic formula. Hopefully we remembered it. You can sing a little song. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. Now, because it is in standard form, we should know what a, b, and c are. A, b, and c. And just substitute the letters in. The numbers in for the variables. Okay, so b squared, that's going to be 64. That's 1 and negative 4. And 2a, which is 2. 2 times 1. Now, the biggest mistake is usually right here. I'm never sure why this is true, but I'm going to say more than half the mistakes would be right there. It is a positive 16, not a negative 16. So there's a negative right here. So the negative and a negative is positive. So be really careful about that. over 2. Okay. So can you leave it like this? No, you must simplify. So I'm going to do the 80 over here, just so I can show you. So the factors of 80 I know are 4 and 20. I can break 4 down again. We're looking for perfect squares. So I'm going to factor them out and break it down. All right, so it can't be broken down anymore. I'm going to leave this as a perfect square because this perfect square of 4 is 2. The perfect square of this one is also 2. So 2 times 2 is 4. Also, you could see if you had multiplied 4 times 4 is 16. The square of 16 is still 4. So then this simplifies to here. So can I reduce that? Can I simplify it? The answer is yes. Be careful. So this is usually where students make mistakes. It's not putting the numbers in. It's really this whole process, making sure your arithmetic is correct. So here, 2 can't go into 8, but when you do this, it has to go into both numbers here and here. So 2 goes into 8 4 times, and 2 goes into 2. Sorry, 2 goes into 4 all 2 times. Ugh, sorry. Right, and there you are. So try factoring first. If not, you can always go to completing, quadratic formula or completing the square. But yes, make sure your answer is simplified. And there's 2 answers. You have the plus and the minus. All right, so these are a little different. These only have 2, and students often get confused between the 2. So again, it's really paying attention to what I have. So here I have the A term because I have the squared, and here I have the B term. So this has no C. This one is an A term, and this one is C. This one has no B. So these are different. You have to recognize. So then, since they're different, you do them differently. Students also forget, one of the first things you should always ask yourself, is there GCF? So for this one, I'm going to say, is there GCF? Yes, I can factor out the 4x. Oops, sorry. 4x. Okay. So 4x goes into 4x squared, x times, into. Again, you're sending, so this is one term because you have the x, right? Because it's square, you should have 2 solutions. Sometimes you can go straight to here. I mean, you can if you know that. So those are your 2 answers for that one. Now this one you can do 2 different ways. Because there's no b term, you can still factor. What are the factors of 49? Well, it happens to be a perfect square. Lovely. So this is 7 and 7. And because it's a special case, you know it's plus minus. Therefore, it's x 7 and x is negative 7 and positive 7. So that's one way. The other way to solve it, because it's no b term, you could add 49 to both sides. And then take the square root. The only thing when you do this, because of this, of the squared, there has to be 2 answers. So it's going to be plus or minus 7. So you can write it either this way or that. It's the same. Okay? Quadratics. What about radicals? They're a little bit different. So you can see here you have a square root, and you can see the square root only goes over those 2. So this is like a big variable, so you're going to move this over to the other side. And I know a bunch of you probably saw that, so remember, trust your gut, trust your math. So when we had a square, the inverse is a square root. So now you have a square root, what's the inverse? Exactly, a square. So you're going to square both sides. This will get rid of your square root, and then you have 81, and then you just solve it normally. Okay. Can I simplify that? Well, now, common factor, I believe, is 2 for the top and the bottom. Okay. So half of 82, half of 8 is 4, half of 2 is 1, half of 6 is 3. I can't reduce that anymore. That is my answer. So take a moment. What does that half mean? So now it's an exponent. Hopefully you remember from last year. Okay, so it is another way to write square root. So this half just means this. No, that's not so bad, right? So why don't you try to solve it, pause it, and solve it on your own, similar to the one. And when you're done, unpause. And remember, because you're squaring it, this whole thing, they just undo this part, right? This part and this part undoes. So you're just left with everything underneath. Everything underneath in the square root is called the argument in here. That's an argument. Okay, so subtract 5 to both sides. Divide by 2. There you are. And it's only one answer for these. Okay. So radicals, roots. Now what about this? This is a cube root. Now hopefully you remember the reason we squared it, because there is an understood invisible 2 here. Hence that's where that 2 comes in that fraction. It's 2, literally square, right? It's a square root, meaning the 2. So when you do a cube root, it's 3. So to undo it, that's right, you're going to have to cube it. That will undo that part. So 2 cubed, not 6. 2 times 2 times 2 is 8. Right, so this is similar to the half, but now it is, so we know if it's a fraction, it's going to be a root or a radical. And the denominator will tell you what goes in front, right? So that goes here. So to undo it again, you're going to, whatever this number is, so if it was 5, you take it to the 5th power. If it was 9, you take it to the 9th power. This is 3, you're going to take it to the 3rd power. Does the root and the power undo each other? So 6 times 6 is 36, times 6, I believe, is 260. You can double check on your calculator. Should have a calculator. Scientific, for this class, you don't need a graphing calculator. Plus, in this world of technology and distance learning, you can use Desmos or something like that for graphing. So you don't need a graphing calculator. All right, here we are. You get that if you paused and unpaused. All right, so you can read this on your own. So we asked 2 things for essential questions, so make sure you have the answers to both. So you may want to write 2 separate sentences, make sure that you're very clear on how to do it. It's, again, making you think and about the process. It's really about the process, not the answer, because every problem will be different. So the numbers doesn't matter what the answers are, but the process will be the same. All right? Good luck. Bye. Oops, come on.